In this video, we're going to take a look at the multiplication rule. So first, let's review some notation. When we write P of A or B, this is the probability that A or B or both occur. Right. That's what we mean when we write the probability of A or B. When we write P of A and B, this is the probability that both A and B occur. And this last notation, probability of B in this vertical line, this notation is the probability that B occurs given A occurs. And so we read this as the probability of B given A. Right? So we read it as the probability of B given A. So this is asking us, or describing, how likely it is for an event B to occur if you know that A has already happened. So to find the probability of A and B, we can find the probability of A and then multiply that by the probability of B given A. Make sure that the probability that's associated with B does in fact take into account the previous occurrence of A. So the probability of A and B is the probability of A times the probability of B given A. So when we're looking for this A and B, we're trying to find that intersection stuff right there. So if this is the circle A, then the probability of A is the area of that circle relative to the rectangle. The probability of B given A is the area of that shaded region relative to the circle A, right? So it's just everything that's in B that was also in that initial circle. So we'll look at an example of this here in a moment, but first let's look at one other thing. Two events, A and B, are said to be independent. If the occurrence of one does not affect the probability that the other event occurs. So they are independent if one does not affect the probability of the other. Otherwise, they are said to be dependent. So if they are independent, the probability of B given A should be equal to the probability of B, because it would not, knowing A has occurred, should not affect the probability of B if they are independent. Probability of B given A is the probability of B. Similarly, the probability of A given B should be equal to the probability of A. Be really careful with these conditional probabilities. In general, the probability of A given B is not the same as the probability of B given A. Those two things don't mean the same thing in general. All right, let's take a look at an example. So here we have employees at a certain company are tested for drugs. The results are shown below. Positive test indicates the drug was used. Negative indicates that it was not. Find the probability of a randomly selected person who uses drugs and had a positive test. So here we want to look at all of those that use drugs. So we're looking at those. Right? So there are 50 people that use drugs. So we're going to take 50 out of 1,000. So there's a grand total of 1,000 people here. There are 50 that use, 950 that don't use. We have 140 here that test positive, and 860 that tested negative. So we are going to take the probability that they use times the probability they test positive given they use. So among the 50 people that tested positive, so out of those 50, how many used? Well, it's just those 41 out of the 50. So we're going to multiply those two values together. The 50s cancel out, and we're left with 41 out of 1,000 for 4.1%. So that's how we use our multiplication rule. In our next video, we will talk about treating dependent events as independent events.